So here we're going to continue to evaluate the given limits and find any vertical asymptotes. So the first limit we're going to do is the limit as x goes to 5 from the right of this rational function 2x minus 3 divided by x squared minus 25. So first thing I'm going to do is I'm just going to try to plug it in and see what happens. So 5 from the right, so I put that positive 5 in there. So I'm thinking of a number that's like just a little bit bigger than 5, like 001, 5.001 or something like that. That's kind of the idea. So if you think about that, like say you plug in, I don't know, 5.01, okay? You multiply that out, you get 25.01. All right. Now, if you subtract 25, you get 0.01. A 5 on the right is going to be a little bit bigger than 25 squared whenever you square that positive 5. And so you're going to get this number that's small but still positive, okay? And so I like to designate that with a positive 0. When I see this positive 0 here and I see that on your test or wherever, I'm going to think automatically, okay, this student is saying, all right, this is a really small positive number, therefore it's going to equal infinity. When you take a constant divided by a really small positive number, this thing's going to infinity. Okay, so that's kind of what I'm looking for on your exams, that notation with the positive 0. Okay, now finding vertical asymptotes, step 1, what I would do is I would factor and then cancel. So if you can factor, great. If you can't, set the denominator equal to 0. Okay, so set the denominator equal to 0 and solve for x or whatever your variable is. So what's my denominator? It's x squared minus 25. Can that factor? Yes. What do I notice about x squared minus 25? This is a square. 25 is also a square. Square root of x squared is x. Square root of 25 is 5. So this factors to x minus 5 times x plus 5. And set that equal to 0. That's step 2 after you factor. Set the denominator equal to 0. And then solve for x. And if I solve for x, I get x equal to 5 or x equal to negative 5. Now, in the numerator, I don't see any factors of x minus 5 or x plus 5, so nothing cancels. So both of these are vertical asymptotes. And you could verify this. See, we've already verified it here by taking a right-handed limit, and we got positive infinity. You would need to do the same thing for this negative 5. All you'd have to do, guys and gals, is you just take the limit as x goes to negative 5 from the right, or whichever one of that same function, okay? So that would get you, plus or minus infinity, whatever it is, and that proves that it's a vertical asymptote by definition. All right, so this next one, we've got another rational, x to the 4th divided by x squared minus 3. Now, this one is a little bit trickier because it looks like it could be a difference of squares. The only problem is 3 is in a square. But guess what? How did we get 5 here? We took the square root of 25. So I'm going to take that same method there. I'm going to take the square root of 3. And so I get a plus square root of 3 and a minus square root of 3, okay? So x minus square root of 3 times x plus square root of 3. And therefore, I'm looking in the numerator here. This one isn't going to factor to something that cancels those linear factors there. So what do we say? We set the denominator equal to 0 and solve for x. So that means I set this piece equal to 0, get x equals square root of 3. And I set that piece equal to 0, I get x equals negative square root of 3. Okay? So no big deal there. Just make sure that you show the work using your left or right-handed limits. Remember the definition for a vertical asymptote involves doing a left-handed limit or a right-handed limit, depending on, which one might be easier for you, okay? And then if that limit is plus or minus infinity, you've got a vertical asymptote at that point. All right, so let's evaluate this limit here. The limit as x goes to 2 from the left. So from the left here, I'm going to plug in this 2 from the left. Now, when I think of 2 from the left, I think of a slightly smaller than 2, like 1.99 or something. Right? Well, what happens here? Basically, 2 minus 2 is essentially 0 in the numerator. This is basically 2, so that's 4. And then that's 8, so that's 12. And then a negative 6 and a positive, basically 2, is 12 negative. So 12 and minus 12 is going to produce a 0. Now, if I have a 0 divided by 0, this is known as indeterminate form. If I take the limit and I get 0 over 0, I'm thinking here maybe there's something that can factor. Okay? Now I'll look here and I'm seeing this x approaches 2, so I'm thinking there might be an x minus 2 factor somewhere. Okay, that's kind of my thought process. And so what do we have to do? We need to take this rational equation, this expression here, and we're going to factor. Now, if you're having trouble still factoring trinomials, you need to go to my college algebra videos in section 1.5, I believe, and it actually it's called factoring AC method, and it will take you step by step on how to factor this. I want something that multiplies to 8, multiply to 8 and add to negative 6. Well, negative 4 times negative 2 is positive 8. And then negative 2 plus negative 4 is negative 6. So that satisfies my criteria there. When a equals 1, it's pretty easy. Okay, so I've factored these two, but what do I see? I see these two factors in common, don't I? So I have to be careful here. I don't just say my vertical asymptotes are, well, if I set this equal to 0, I get x equal to 2, and I set that equal to 0, I get x equal to 4, right? I can't just do that, because what's going on here? These two factors actually cancel each other, and it produces what's known as a whole, okay? So that whole, you can see this graph over here at x equal to 2, you see there's a hole punched out, okay? And x equal to 4, you see that there's a vertical asymptote going on there, okay? So there is a vertical asymptote here. There's no factor that cancels with this x minus 4. However, this x equal to 2, just because you set the denominator equal to 0 and you solve it there, don't forget you've got to cancel if you're trying to find vertical asymptotes. Okay, so I have to cancel those two factors there. All right, so let's go ahead and we're writing the factored form down. So I take this and I write the factored form here. Okay, and so since I'm taking a limit as x goes to 2, I can factor these two things right here. I can cancel them and not have to worry about it, because the limit at a point was with the possible exception of that point itself. Okay? So the limit as x goes to 2 from the left, all right, the limit as x goes to 2 from the left is 1 over x minus 4. So I literally canceled these right here. Okay? And when I plug a 2 in, what do I get? I get 1 over 2 minus 4 is negative 1/2. Okay? And that makes sense because when I take that limit as x goes to 2, my limit value is negative 1/2 there. Okay? So all is right in the world. It's just a whole. So what does that tell me? That tells me since this limit, this left-handed limit is equal to a number, then you do not have a vertical asymptote at x equal to 2. So this is how you're going to prove to me that there's a hole. You're going to take that left-handed or the right-handed limit, or if you just want to take a regular limit, that's fine too, okay, for holes. All right. What about the limit as x goes to 0 of 1 over x squared? So 1 over x squared, well, if I see a limit, then I need to consider the left and the right-handed limit. Okay, I can't just do the limit. All right, I need to do the left and the right hand. So the left-hand limit says, all right, I go on the left side, so I plug in a positive 0. Now, a positive 0, 1 over a positive 0 is infinity, but 1 over a positive 0 squared is like infinity squared. So that's like a really big number, right? So this thing is definitely going to infinity, okay? So you see the squiggly equals, that's a not exact, okay? So if you wanted a better proper notation, then you could have just said 1 over positive 0, and that gets you positive infinity there. Okay, so that'd be kind of what I'm looking for, okay? Now, the left-hand side, okay, hopefully I said right-hand side there. The left-hand side here, I want numbers that are slightly less than 0. And so if I square that, what's going to happen to a number that's negative that's squared? So I take like -5 and I square it. What type of number do I get? I get a positive 25. So no matter if the number is positive or negative, when you square that number, all of a sudden that becomes a positive 0. And so then you get positive infinity, okay? And so what does that tell me? That tells me that this limit right here is therefore equal to positive infinity there. Okay, so very, very powerful stuff there. So when you're proving vertical asymptotes, you want to take left-hand, right-hand limits. The only reason I didn't do it here was because I was just going quickly, but you would take a limit. You'd take a limit as x goes to, square root 3 from the right of, that function right there. Okay, and then you'd show, hey, look, this thing, whenever I plug it in, it gives me positive infinity, blah, blah, blah. Okay? All right, guys.